off your trot.
Hello, I should be unmuted now. Am I unmuted? Excellent. Good evening, everyone. Right. For those of you who don't know me, I think everybody does. I've been a member. How long have I been a member? Donkey's years. More years than I care to remember. And those of you that attend the Wakefield show will have seen me probably squirreled away in a corner in the theatre, hiding in the dark. But generally speaking, looking after the AV, because that's sort of my background. I have a background coming from sort of theatre and entertainments and then into AV. My screen flickered then. We just had a flash of lightning, I think. Sorry about that. Yeah, so I came into audiovisual stuff and then picked up with computery stuff along the way, with me starting with the good old BBC and then an A5000, I think it was, and then an Archimedes and then a RIS PC, or was it the other way around? I forget. So long. Yeah, I thought Peter was going to be joining us this evening, but he obviously hasn't done. I've introduced Peter as a co-conspirator for looking after the show theatre AV stuff, and that's how I got into this line of stuff. So what I've been asked to talk about tonight is a couple of things, but the first thing we're going to talk about is the capturing of video display from things, well, from other computers, but particularly in this case from the Raspberry Pi running RISC OS. We've done this a few times at the show, admittedly with varying levels of success, because what we've done is take a feed from the presenter's computer, which has obviously gone to the projector onto the big screen, and then we've taken a little tap off that signal into a capture device so that we can then record the proceedings on my laptop computer, and then we can make those presentations available to everybody after the show. So we do have the club's own YouTube channel now. So if you go and look for WROCC or Wakefield Acorn Wakefield RISC-OS Computer Club on YouTube, then you'll find all the videos from past show theatre presentations. So the other reason that it's useful to be able to capture video from other computers is for training purposes, and particularly I think with the rise of the popularity of things like the Raspberry Pi, RISC-OS Direct. Hopefully that's going to get RISC-OS into many more people's hands. I think it could be very useful for people to do little training videos, even if it's just a 2-minute presentation of how to do this, how to connect the network system, how to use networked drives, how to use various other things. I think it's much easier and nicer to watch a short video of someone showing you how to do things than it is to read half a web page half a page full of text. So now, all being well, I'm going to switch my camera off because nobody wants to look at me all night. So I'm going to switch over to just bear with. I'm going to change my camera to Droid Cam. How's that? Now you should be seeing my capture device and my hand there. How's that? Is that backwards? Can somebody just confirm? Are you seeing that backwards? Does that say that's backwards, isn't it? No, is it? It's
Zoom,
okay.
Zoom makes it back
okay,
for you, but corrects it for everyone else.
I see. Fine. That's confusing the hell out of me. Okay, that's fine. So this is the device that I've been using. It's by StarTech. This was actually quite expensive. I mean, I bought it about 4 years ago, something like that. Before I left the university, I've left there 3 years. So about 4 years ago, I bought this. It's quite nice in that it has a HDMI input. It has a DVI input. It has this multi-pin input here, which accepts composite video and what's the other? S-video, if anybody remembers S-video. But that can be very useful because you can actually use this device for capturing outputs from things like VHS players, if anybody remembers VHS. That just connects on USB 3 on the back. So I shall plug USB 3 in there. And the other end of that, hopefully, this is where everything goes belly up. Let's have a look. Are we? Oops, there we are. Nope. Everything's backwards. Excuse me a second. I'm just going to turn off the reverse video, otherwise I can't see a thing that I'm doing. Video settings. Mirror my video. There we go. There we go. Things are actually in the right direction now. So that's the top of my computer there. So back to this device. So that's the StarTech device. The only thing that I don't like about the StarTech device is that it has I've lost it. Everything moved. It has an HDMI input, but it doesn't have a loop through for the HDMI. So if you want to, for example, capture the video from somebody's computer and at the same time send it out to the projector or another screen, then you're going to need something like that, which is a 1-in 4-out HDMI splitter. But that wasn't terribly expensive. That was on Amazon, probably about £20, something like that. So that wasn't too bad. So I'm going to put a feed in from Lego Comp. And let's swing over to Lego Comp. There is a Lego Comp. Good old Lego Comp. It's a Raspberry Pi in a Lego box. And I'm going to plug the other end in there. Now, I can see some of you looking confused about, let's zoom in a little bit if I can. No, I think that's maximum zoom. The little chappy on the top there, because when I set this up originally, I had some problems getting it to talk to the network, and somebody told me that it needed a driver. So he's the driver. Sorry about that, I'll get my coat now. Anyway, so that's Lego Comp. And I'm going to zoom right out, then I can actually see what I'm doing. This software I'm using here, by the way, is something called DroidCam. For those who don't know, it's an app that runs on an Android smartphone, and you run a little client on the PC or Mac, and it basically allows you to use your smartphone camera as your webcam. And obviously that's very useful because then you've got control over things like zoom, and you can put it on a nice tripod and sweep it around and things like that. So that's basically my rig at the moment. Now, to capture the signal that's coming from the Lego Comp to the StarTech box, we use some software called, have I got permission to share? It looks like I have got permission to share. That's useful, isn't it? So I'm going to switch over to my screen.
I
Nope.
think of everything, Ruth.
Thank you for that.
Sometimes.
Go to the correct screen, and it always helps. So to actually start capturing that now, I'm going to use this software called OBS Studio. Now this is actually running on a Windows PC, as you can see here. But it also runs on the Mac, and it's also available on Linux. I've actually got a laptop that's running Ubuntu Linux, and OBS works very nicely on it, even though it's a fairly old laptop. So it is good. It is good. Now, OBS, Open Broadcast Software, or Open Broadcast Studio, depending on which version you get, it is a very clever bit of software. It's very good. You can define sources down here. Are you seeing my screen okay? Can you just confirm? Yep, that's great. So you can see sources down here. And in the video capture device, you should now be seeing the output from the Lego comp. You're not seeing anything at the moment because Lego comp isn't running. So I shall plug Lego comp in, and with a bit of luck, it should start booting. Oh dear. So that's Lego comp booting, so I can close that. So what you can see is happening here. OBS gives you an option of having lots of different input sources. So for example, you can have a studio mic, which is what I'm using here. I've got, you can choose to display a particular window. You can display graphics. So I've created some WROCC branding, as you've seen. So if I switch back to a scene here, a scene is a collection of different sources. You can even have a scene that consists of a collection of other scenes, which is really clever. So I've gone to branded capture there. So what we've got here is a graphic with the WROCC logo, scrolling text underneath, and the input from the Lego comp displayed nicely in this window. We have two windows. So the right hand window is showing what we're actually recording, or would be if I started the recording down here. You can also use this for live streaming. So if you actually want to do a live tutorial with anybody, you can send this out via, I think it's via Twitch or via YouTube, or I think you can do it via Facebook. I'm not too sure, but I've never streamed anything anyway, so I've never really looked into that. But the recording is what you'd use most, or I'll use most, and you can record in all sorts of different formats. MP4. You can record it in. I think you can even record it in flash video, so all sorts of different formats. But I usually just stick with MP4. So that's what's actually going out. This window is your preview window. So you can switch to a preview, see what it is that you want to display. And when you're ready with whatever it is that you want to display, then you can just click this transition button here, and that does a nice crossfade to show the new source, or the new scene, I should say, which is pretty good. So I can just flick back there. So you can see, hopefully now, if I remember to switch the mouse on, that always helps, doesn't it? There. So that's a live capture now coming in from Lego comp. It's a bit small on here, but I can cope. And it's very, very useful. When that is captured, it's capturing at full 1080p. 30 frames per second, which is more than adequate for this sort of thing. You can get more sophisticated gadgets, capture gadgets, which will capture at 60 frames. Obviously, that's probably quite useful if you're using, if you're doing games or anything like that. But
Ruth,
I think, yeah.
Ruth, sorry to interrupt. Just sometimes your audio level's dropping, so I presume it's just your proximity to the microphone. I don't know if you can crank the gain up a bit, or
it is probably that.
It's all right when you're speaking close, absolutely fine, but just now and then it does drop quite low.
Is it when I lean over like that?
I don't
that's
know, because I
probably
can't see what you're doing. I'm looking at your screen.
Sorry about that.
Not to worry, just thought I'd let you know.
Okay. That's great. I'll try and keep on axis. So that, I mean, that can bring me round to the audio rig that I'm using here to do these sessions. I'm involved when I'm not riscossing or clubbing or various other things. Then I'm involved with a local charitable group of, how can I put this politely, silver servers. They're people, most of whom are well retired, but have never been involved with computers before. So I host Zoom meetings with them, and I'm also producing some little short training videos to show them how to use various aspects of their laptops and things like that. So that's another reason why I've got this slightly over the top but somewhat elaborate setup here. But that's OBS. OBS is absolutely brilliant, and as I say, it's available in Mac format, PC, Windows format, and Linux. So it is really useful. It's open source, it's free. What's not to like? And it works with pretty well any video source or audio source that you can throw at it. For those of you who are familiar with any sort of music software, if anybody uses, digital audio workstations or music composition software, you'll be familiar with a thing called VST, Virtual Studio Technology, which allows plugins to go into the audio path. Plugins you can use for things like audio compression or equalization, or adding effects like reverb and delay and all that sort of thing. And OBS with an extension will support VST plugins. So if you can download some free VST plugins, which there are plenty available out there, then OBS will do that as well. So if you've got any problems with, say, your microphone not sounding too good, you can use a VST plugin to do a lot of correction, clean things up, gate it, get rid of noise, filter out hums or anything nasty like that. So that's pretty much OBS, capturing a live source from Lego Comp, which, as you see, has got a nice clean installation of
it's the audio level again, Ruth.
Yeah, I'm wandering off axis, that's why. It shows how good the microphone is at rejecting stuff from the side, doesn't it? So I'll come back out of sharing that screen. I'll come back to me, and I'll change back to, lots of switching around of videos and things here. I'll come back to my normal webcam. Yay! Back again. Oh, getting blinded. The sun's setting over Stocksbridge. Oh dear. Anybody got any queries on what I've talked about so far? Just feel free to hit your space bar and speak up. Very quiet. Okay. So yeah. Where are we? I've even done notes.
The thing is, I'm not sure how to unmute everybody in all one go.
On your output, can you hear me?
I can, yes, I can.
On your output, you can actually go to full size screen, can't you? You know, you have your two small screens, but there are times when you just want the one output screen, so it can go full size.
On, you mean the output from OBS?
Yes.
Oh yeah, the output is recorded at full size. you can fully define. If I switch back in, sorry, I should have shown you that. I'll switch back into sharing that. Share screen. Come back into there. Yeah, you can take any input, any video input, and you can move these sources around to whatever you want them to be. So when you transition across, you've got that. I can go to a full-size capture, can transition across there. So yeah, not a problem at all. You can resize all the windows to be whatever you want them to be.
But on the output side, that can go to the full size of your screen, as opposed to just a small.
Oh, absolutely. Yeah, the recording is always at full full size 1080p. Yeah, yeah, good point. Right. I'll just go briefly through the audio system that I'm using then. As you can probably see, I've got a whacking great microphone here, completely over the top, just like me on a Saturday night, but that's another story altogether. This is a very nice mic, actually. It's an AKG C3000. I shall bring it up to the microphone. There you go. C3000 with a nice hefty pop shield. So when I'm saying things like Peter Piper picked a peck of pickled pepper, and put that on, and that should hopefully get rid of any plosives from when I'm saying things like Peter Piper picked a peck of pickled pepper. And if I switch back to my Droid Cam, here we go. Oh, this is so complicated. Droid Cam, right, we're back on Droid Cam. So, so you've seen the microphone. I'm going to take the Droid Cam, and what we've got down there is the microphone is going into a nice little baby Behringer mixer here. The benefit of that is, well, first and foremost, the signal from the mic is not very powerful, so you need to go through a preamp anyway. But it means I've got absolute instant control over the volume of my microphone there. I can turn my volume down and back up again, hopefully. I can roll off. We've got 3-band EQ there, so I've got bass, mid-range and treble. I can roll off anything that's causing any problems. The output from there on these two jacks is going eventually into that box there, which is a card plugged into the back of the computer. This is an extension to the card that's plugged into the back of the PC. It takes 4 line inputs and it's got 4 line level outputs. So it's 4 in, 4 out. I've got a full jack panel there, patch bay, which is not fully wired at the moment, as you can see. I've got, the reason that I've got all that, let's see if I can just get this Droid Cam back on again. It's very annoying. Technology, eh? Is it the curse of the WROCC?
It is the curse of the WROCC, yes.
Let's lock that up. So we should have this back now. We should have this back. Droid Cam source. How's that? That's better. And it's mirrored it again. It's so annoying when it does that. Yeah. Right. So where are we? We've got the line level into the computer and line level out. Line level out feeds via the patch bay. A couple of monitors. So I've got a nice monitor up there. It's Behringer, but it does the job more than adequately. Moving across, I've got, yes, it's a cassette deck. For those of you who don't like cassette stuff. No, I use a cassette for digitizing an awful lot of my music collection. Though some of us can remember cassettes. Of it, there's a VHS player, so I can use that for capturing video VHS recordings. I've got a monitor up there so I can see the VHS that I'm actually capturing. And then we've got the other audio monitor over there. So a bit far apart, but you know, I can cope. So it's quite a decent little audio rig. And I think I use what is it I use? Reaper more than anything else as my DAW of choice, because it's incredibly good value for money. So that's the audio rig that I'm using. How have I done time wise? How are we doing time wise?
Well, all right. I mean, don't want to keep people away from their bed, but I think we're a long way off that yet. Because you were going to say a bit about your about the media server, weren't you?
Indeed, yes.
Yeah.
Sorry, completely forgot about that.
That's all right.
Oh.
I mean, obviously not at a normal meeting. It takes up quite a bit of time because you're just describing all the installation. But I think maybe just an overview would be helpful to people.
Yep, no problem. So a while ago, I set up a media service. It's open MediaVault is the software. It's a Linux distro, and it runs on a Raspberry Pi. Runs on various things, but I'm running it on a Raspberry Pi. And if I switch back to Droid Cam again, come on, we can do it. We can do it. Fingers crossed, everyone. Okay, so we're back there. So, let's shine a light under there, and now with a bit of luck, you can see the underside of the shelf there is moving in a Raspberry Pi glued to the underside of the shelf. Sorry if I went off microphone there. So a Raspberry Pi glued to the underside of that shelf, because it seemed like a sensible way of getting it out of the way. In that little box, there's a Raspberry Pi running MediaVault, and it's actually running on a Raspberry Pi 2. The storage is 128 gigabyte USB drive. I was intending to, at some point, replace it with a spare 240 gigabyte SSD card that I've got, but I haven't got around to doing that yet. It's on my list of things to do. But the beauty of the MediaVault is that you can access it via practically anything. So with a bit of luck, I've made a shortcut here. So this is now connecting to MediaVault. It's just sitting there on my network. So if I could log in as admin, and then you'll be able to see so all the things that it does, which is absolutely amazing. As I say, free software. It's a Linux distro. Sits on a 8 gigabyte micro USB, and then it stores your stuff, and it gives you access via FTP. You can use an Apple filing system if you really want. FTP access, mini DLNA, which is very useful if you've got anything like a network-enabled media device anywhere in your house, either your television or your hi-fi amp or anything like that. I use it so that my entire music collection, which sits on that 128 gigabyte USB stick is accessible over my network anywhere in the house, or out in the garage if I want to. It runs SMB, Samba as it's otherwise known, I think. Connect to it via SSH if I want to. It runs NFS. It also runs something called rsync, which I've only just looked up, and that could be quite useful for automatically getting it to synchronize with the folder on the PC, so that whenever I add any music, it automatically gets synchronized to the same folder. It's been running. If I come down here, let's have a look. Information. I think it's there. Let me just look. Let me look on my notes. It is under diagnostics. Diagnostics. System information. If we look at the uptime there, uptime 79 days, 10 hours, 25 minutes. So yeah, 79 days, and that is since we had a power cut. And the power gets restored, and the thing boots up again, and I've never had to do anything with it. It just sits there, dishes out my music files whenever I want them, and I also use it for storing as well as my music files. I can just use it as a little temporary store for moving things from one computer to another, or from a phone to something else, or whatever. It's even, I'm just going to launch an FTP. So, go away. So yeah, FTP client, FileZilla, and tell it to connect to that. So if I go and look in my music folder, don't laugh. Yes, I've got ABBA on there. So in the music folder, yeah, I've got lots and 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 lots of music. I can store some photos on there. This is accessed via FTP, which is nice and easy. I've even got some videos stored on there. Oh, look, a couple of Doctor Who's. Who'd have thunk it? And
I love ABBA, by the way. I'm not ashamed to say it.
There's nothing wrong with ABBA. And then MISC, just bits and pieces. Oh, look, Riscos Direct. Who'd have thunk that as well? Yeah, it's just a temporary store. I can use it to transfer stuff from one machine to another. I can access it under lots of different protocols. So in theory, I should be able to access it directly under RISC-OS via an FTP client at least, and hopefully via SMB or something else. I'm not quite sure what yet. But that's a bit of experimenting, isn't it? That'll come up. For the it's actually a Raspberry Pi 2 that's actually running that. It was originally running on a Raspberry Pi 3, and then I thought, well, it's a bit of a waste of a Raspberry Pi 3, isn't it? So I swapped it out and got it running on a Raspberry Pi 2, and my Raspberry Pi 3 is now promoted to Lego Comp. So it's actually being used as an actual RISC-OS machine. Yeah, the MediaVault is a very, very handy little gadget, and as and when I do actually get around to connecting a 240 gigabyte SSD, it will obviously be twice as useful as it is now, a lot more useful than it is now. So that's MediaVault. If I come back to the general settings, you can just define what protocols you want it to run. Let's have a look. Storage. So that will show you what disks you've got connected. So USB flash drive, it's supposed to be 128 gig. Which file systems you're using. So it is absolutely amazing. You can define users, everything that you can do under Linux, obviously, you can do on this. So you can define who has access. So if I was in a house with other people, I could grant them access. So for example, my own access there, I can grant myself full read and write access, but everybody else I could perhaps just give them read-only access, so that's useful. Same with groups as well. You can put people into groups, which obviously there's only me here, so it's a bit pointless. And you can define which folders you want and who has access to them. It's very, very clever.
Bruce Brown's just popped a question in there on chat saying, how do you search your audio? I think that's what it said. Lost it now, it's disappeared.
How do I search my audio?
Yes, I think that's what it said. Unfortunately, that particular, oh, here we are. How do you search your music? Is it tagged?
That's a very good question. I don't think I do. I tend to just stick an album on and let it rip. You see, I'm a 70s child. And
thank you for making me feel old.
Okay, I'm a 60s child, really. But I don't particularly search as such. No, I'll be honest, it's not something that I've ever worried. When you're using a media device like my amplifier and my TV, everything is just displayed in by albums, by artists and albums. It must be tagged. It must be tagged. I never even thought about it. That's a very good point. If I just open another window here now, yeah, okay. This is I've just opened up a file explorer window, whatever you want to call it these days. So under network locations, it finds this thing called Ruth Media, which is the media server, and it allows you to browse it in different formats. So you're not seeing it in the same directory structure that I created. If I go into music, you can see that things are being sorted by album or by
Frozen again. If we don't get Ruth back reasonably shortly, we'll move on. There's another question there. Ruth, can you hear me? Well, I think what we might get Ruth back later. It's like the BBC. This is. So I think the best thing to do now is to move on to Cliff. Hang on, let's move on to Cliff, who's going to talk to us. Can you hear me, Cliff, by the way?
Turn on the microphone for him.
Yeah, I'm just trying to
turn on your microphone.
Ask to unmute. Just a minute.
I am back.
Oh, are you? Okay. Well, before you disappear again, do you want to wrap up? There's another question for you. How easy is it to set up software and minimum spec? I think I know the answer to the first question.
Right. The MediaVault, as I say, it comes down as an image, and you flash it to a micro SD card using, is it, what's it called? Balena Etcher. Is that the one? And you fire it up, you remote login via a web browser, and it's, I wouldn't say it's difficult to set up. It has its idiosyncrasies, definitely has its idiosyncrasies, but I wouldn't say it's difficult. It's it guides you through most of it. The original version was probably a bit of a pain, because you had to go backwards. So you'd set up new folders, and then you'd have to go and give people rights to those folders. And the new version seemed to do things slightly more streamlined. So it's not difficult. It's not the easiest thing in the world, but I wouldn't call it difficult at all. If you've got a basic understanding of folders and giving people access rights and things like that, you should be fine.
I seem to remember your biggest problem when you were trying to get it going on the Pi 2 was that you thought the thing had frozen, when in fact it just took about 15 minutes to do something.
Yes, exactly. It was sitting there asking for a password, and I was bashing the keyboard away, putting the password in, and it was just ignoring me. But if I'd have waited, like Rick's just said, about 15 minutes or so, it would then have scrolled a load of stuff by and then presented me with a different screen. So I mean, I did a sort of a little PowerPoint thing, didn't I? So if anybody's interested, drop me a line, and I'll send those PowerPoint slides, PowerPoint slides out to you, if that's a help.
Another thing.
That'll be interesting. Right.
I think the PowerPoint slides are actually up on the website. If you're a club member, you can get them from Ruth's meeting reports. I remember putting them back up there when I updated the site.
Have we done that already? My memory's so good these days.
Another thing on chat, Ruth, it says, I think that the system view was probably using DLNA, which is tagged according to a quick Google.
Yeah, that seems to be what's going on here.
Right. Okay. I think maybe time to move on. By the way, I believe Peter Richmond's joined us. If you just want to say a quick hello to him.
Hey, Peter.
He's just waving there. Right. So it's over to Cliff Hatch, who is in Edinburgh with a proper computer, or a facsimile of it.
Yes, thank you, Rick. We're going way back in time now. For about 10 years, from the mid-1960s to the mid-70s, the PDP-8 was one of the most important computers in production. There aren't many of these left in working order these days, but it is possible to own and operate one of these reduced scale replicas. These were created by Oscar Vermeulen, who has a website called Obsolescence Guaranteed, where you can read about these and buy them in kit form. And you can also read my review of the kit in the October 2019 newsletter. I'm going to demonstrate this in a moment, but before I do, I've got some pictures of a real PDP-8 to show you. So I'm going to go to shared screen. Go to full screen. Can you see a picture there?
Yes.
Yep,
Yeah,
fine.
Good. There were quite a number of different models of PDP-8 manufactured, but I think probably the best known is the 8E and also the 8F, which looked almost identical. And the one in the photograph is an 8F. And I first encountered these right at the end of my school days, when I went with some friends to the National Physical Laboratory in Teddington for a one-week computer course. And they had quite a lot of these, and they were all working with their lights flashing, surrounded by teletypes, that's electromechanical keyboards and printers, and paper tape readers and punches, and the whole atmosphere was really enthralling. And I think most enthusiasts can remember the first computer they ever used. And it just happens that in my case, it was one of these. And I thought that front panel was a thing of wonder. And I really wanted to understand what was happening behind it. So we can see here the name of the company that made the machines, the Digital Equipment Corporation, better known as DEC, based in Maynard, Massachusetts. And PDP stands for Programmed Data Processor. This panel gave us direct access to the machine's registers and memory, but very much on the machine's terms, because everything here is represented in binary. About the only concession to the human operators is color coding. The yellow and brown keys are in groups of 3, and that just helps the operator to think in terms of concise octal numbers rather than long strings of binary. This selector switcher here is for choosing which register you want to look at. The top one is there all the time, the memory address, but there are the accumulator and various other registers you could select with this. Now, how much the operator used this panel depended on what kind of configuration of system you were using. If it was a paper tape system, you had to use it routinely to load tapes and to set start addresses for running them. But if the machine had a disk drive and an operating system, you would just issue all your commands through a teletype, and you probably wouldn't need to touch the front panel at all. You can operate and program the machine entirely through the front panel if you want to, and I think that's quite a fun thing to do, but it's not how the machine was normally used. Another use for the panel was diagnostics. When things went wrong, you could get some good clues about what was happening through this. It was a 12-bit machine, and the term RISC hadn't been invented in the 1970s, but that's what this is. It's a reduced instruction set machine. It had only 8 instructions, and these were designed to get the best performance from minimal hardware. And I think the instruction set was a really great piece of design. It's hard to imagine this now, but in the 1970s, that was an extremely small computer. They called them mini computers. And the other machines that were around at the time were mainframes. And these were very expensive, very large, often housed in custom built buildings with powerful cooling systems. And they needed a dedicated staff to operate and maintain them. PDP-8s were quite different. They were much cheaper, small enough to wheel in and install almost anywhere. And you had to train up 1 or 2 people to be able to start the machine up, and you needed a maintenance contract, but that's all. You didn't have to have a full-time dedicated staff. And because of that, these machines started to appear in all sorts of places where there hadn't been access to computers before, particularly research labs and educational establishments, but other places too. And I think what was really driving their development was the need to do high-speed calculation to solve problems in science and engineering. At the beginning of the 1970s, we had slide rules. And a couple of years into the decade, we had electronic calculators. But in engineering, there are a lot of problems that are solved by iterative methods. And trying to tackle those with a slide rule or a calculator is really hard work. And the chances of getting the right answer at the end are pretty slim. And you always had to be reworking and checking everything that you did. And these machines offered a wonderful alternative. They took all the drudgery out of the process, and they gave reliable answers. And for those of us who enjoyed working with computers, it was even better than that, because not only was the drudgery removed, it was substituted by the art of computer programming. Now, the machine in this photograph is one that I looked after at work for several years. And when it came to the end of its life in the early 80s, I bought it from the company because I didn't want to see it destroyed. and I enjoyed using it at home for some time. And eventually it developed hardware faults that I was unable to fix, at which point I placed it in the safe hands of another collector, and it's still preserved in his collection today. So these things were built a bit like a filing cabinet, but with a very heavy, strong steel frame. And you could withdraw the processor from the cabinet, and you can see here it's very modular. It's a stack of cards, all plugged into a back plane at the bottom of the box. These strange shapes here are just handles that we use to get hold of the cards, to pull them out and push them back in again. And these rectangular things are jumpers, which provide additional connections between the cards where that was required. And this is the same view looking from above. So you can see the back plane. And I don't remember what all these cards are, but the one at the bottom of the picture is the front panel. And then the cluster of cards above that comprise the processor. The one on its own is a serial input-output card, and the temporary lead attached to that was something I put there to use my Atari 800 in place of a teletype. And the green cards are the magnetic core memory. The memory came in batches of 4K, and each batch was 3 cards, 2 drivers, and 1 card with the actual magnetic toroids on it. So we have here 2 cards with handles, and sandwiched between them, but you can't see it in this picture, is the card with the toroids on it. And on the next picture, that's the toroids. That's actually the magnetic core memory. And it's impossible to see the toroids. They're really small, and even if you have this thing in front of you, rather than a low resolution photograph like this, it's really hard to pick them out with the naked eye. This structure just has the appearance of a very intricate knitting. And I don't know how they made these. I understand that the process was never fully automated. So there were actually people with very good eyesight and very good dexterity threading thin wires through these minute cores. And this strikes me as a really challenging manufacturing task, because if you got one wire through the wrong core or not through a core at all, that would disable one bit of the memory and make the card useless. But the engineers did find a way to do it, and they managed to make these at reasonable cost, and they were reliable. This particular machine also had a disk drive in one of the lower drawers, and what we're looking at here is the drive with the front cover removed. And the actual platter is in an enclosure at the back and can't be seen in this picture. But what we can see here is some switches that were used for setup and testing. And behind this massive wires was a row of cards that performed all the logic associated with reading and writing to the disk and transferring to and from the computer's memory. This was a direct memory access system, so that it could transfer data into the computer without going through the processor. And this is the wiring on the back plane that is supporting that row of cards. And as you can see, it's quite complicated. And I've got on the next slide a close-up view. I can zoom in a bit more. And I don't know if you can see, but these connections are all wire wrapped. So the bare end of each wire is tightly wrapped around a square pin. And apparently this gives a very reliable joint. And from my experience, the machine was reliable. It ran for all the years that we had it and never gave any problem. So it strikes me as another very challenging manufacturing task. Although in this case, if you made a mistake, I think it would be rather easier to go back and correct it, you could just remove the offending wire and put in a replacement. So before I move on to the demonstration, I want to show you this close-up of the replica panel, because you won't see the detail when I go to camera view. And this is a model of an earlier PDP-8, it's an 8i. And the panel shows pretty much the same information, but one obvious difference is there's no selector switch. It just displays all the registers all the time. And for a replica, I think this is very good, because the more flashing lights, the better. And this vertical column of lights here show which was the last instruction to be executed. And we've got one light on showing us that it was a TAD instruction, which stands for two's complement add. And there are 8 of these lights, one for each of the 8 instructions that the machine can recognize. So I'm just going to unshare my screen again. Oh, I can't see. 1 minute, I have to come out of full screen. That's better. Okay, can you see me on camera view now?
Yep.
Good. So what's inside here is a Raspberry Pi running the Linux operating system and an emulator called SimH. And SimH can emulate the PDP-8 and just about all of the disk drives and tape units that were produced for that machine. But the easiest way to visualize it is not to think about what's actually in there, but what it's pretending to be. It's a PDP-8 with its own disk drive with an operating system called OS8 loaded on that drive. DEC wrote OS8 for the PDP-8, and it's now available free on the internet, and the manual for it is also available free. What's in here is a Raspberry Pi running the Linux operating system and an emulator called SimH. SimH can emulate the PDP-8 and just about every disk drive and tape unit that was ever manufactured for the machine. But it's easier to think not in terms of what's actually in here, but what it's pretending to be. So we can view it as a PDP-8 with its own internal disk drive, and loaded on that drive is an operating system called OS8. DEC wrote OS8 for the PDP-8, and it's now available free on the internet, and the manual for it is also available free. So OS8 is up and running, and it's waiting for me to type in a command. And I have a keyboard here and a monitor, and these are going to play the part of a teletype. So the command to get a directory listing is dir, and when I press return, you'll see the lights flash as the processor is busy for a while, and you'll see a directory listing appear on the screen. Now, I know you can't see the detail here, but this is just to give you an impression. There's a speed control in the emulator, so you can run it at a realistic PDP-8 speed, and that has been set. But the monitor is much faster than a teletype. If we'd have done this on a teletype, it would have taken about a minute to get that output. And OS8 has all of the usual commands you'd expect for a disk operating system. You can delete files, rename them, copy them, and execute them. And the command to execute is exec and file name. And this is a Fortran program that I compiled earlier. It's calculating trigonometrical sines by summing a mathematical series. And if I press this switch, it stops. And what I've done is I've put it into single step mode. So it finished the instruction it was working on, and it's now frozen. And if I press the continue switch, it advances one machine instruction at a time. And you can see the state of its registers changing every time it executes an instruction. Now, for those of us who know how computers work, there's no surprise here. All this is illustrating is that whatever language you're using or whatever application you're running, inside the machine, it all comes down to very simple instructions executed one after the other. And the instructions are in binary, and the data they operate on is also in binary. But I think it's so nice to be able to demonstrate this, because you can't do this on a modern machine. Modern machines never stop. They might slow down a bit if there's not much for them to do, but they're always checking hundreds of things in the background. And I think it's nice to be able to slow it right down to a speed that the human mind can comprehend. And if I take it out of single step mode and press continue again, it resumes from where it left off. Now, for me, this is all about nostalgia. I really enjoy using this kit. But for anyone with an interest in computer history, I think it really brings the history to life because it's a working machine. It does arouse curiosity. If you have one of these running on your desk or your bookshelf, no one will walk past it without asking, "What's that?" And I think the kit might have some educational value too, because single stepping through programs is maybe as near as you can get to seeing inside a computer processor when it's running. And you can only do that effectively with a very simple machine like the PDP-8 that has just a few registers. So to sum up, I've had a lot of fun playing with PDP-8s over the years, and thanks to this kit, I'm able to continue doing that. And I recommend it to anyone with an interest in computer history.
Okay.
That's
Yeah, that's grand.
My auto cue fell over.
Yes, I heard the crash.
I got my notes on the clipboard and it fell over.
Yes. For the benefit of anybody that might be wondering, this part of the talk was recorded subsequent to the meeting because the video recording stopped abruptly at the point where Cliff was describing the single stepping.
Yeah.
Maybe Zoom went into single step or something. Oh, that's grand.
Good.